Thanks, everyone. So today we will be talking about our experience with continuous delivery at Pragma for cloud-native applications. So we don't develop products ourselves, but we work with customers who need our help with doing continuous delivery in this new term that is called cloud-native. So first, let me introduce myself. I work as a DevOps consultant at Pragma. I have a PhD in computing science with research background in cloud computing and model-driven engineering. And for the last year and a half at Pragma, I have been working mostly on automation, software processes improvements, and cloud and Kubernetes and all the related technologies around that. I also created a small tool called Helmsman, which is a continuous delivery tool for Helm charts that uses a declarative desired state, which we will see towards the end of this talk in a live demo. And first, let's start with why DevOps. Thankfully, Johan did a good opening this morning, so I think hopefully you are convinced that you need to do continuous delivery. But for those who are not, then I would just refer you to the State of DevOps report, which shows you in numbers that continuous delivery, if you do it right, will give you faster deployments and much lower risks of failure. So what is cloud native, this new term that is coming around for the last few years? If you search for that, you will find lots of answers and lots of definitions from different people, different companies, but there is no standard thing. However, this book about cloud native infrastructure tackles this definition issue from a nice angle, which is how those cloud native apps actually impact cloud native architecture, infrastructure. So at our work, usually in Pragma, we deal with customers who come and they would love to have things like this. They would like to develop fast. So they are looking for agility. And basically, sometimes it can be useful for them to use microservices, depending on what their system is. Sometimes it can be more efficient or more agile for them to use monorepos and so on and so forth. But they would like to achieve agility as one thing. The other thing they look for is determine the status of the app. Like they want to be able to always determine what's the current status of their app. So they are after operability. This can be achieved by building in health checks in your application logic so that your application itself is reporting its health status instead of relying on some operation engineer somewhere sitting somewhere and trying to figure out what's the status of your application. They also would like to gain business insights about their applications. So they would like to know not only is my application alive or not, but is it actually functional as it is intended? What is my service level that I am providing? And for this, they could use, or it can be called observability, and for this they could use metrics. So your application can generate metrics about what it's currently doing, and from those metrics you can obtain things like service level indicators or key performance indicators and so on. And finally, they like to embrace failures. So if you have attended the keynote in the morning and you have seen lots of several examples of how things can fail, you need to build your application in a way that embraces failures and assumes that everything will fail eventually. And for this, they can use techniques like graceful degradation, for example, the fallbacks, as was mentioned in the morning, or also design their application to, for example, disable certain features if some dependency is failed or things like that. So basically, we have a cycle of develop, release, and feedback, and the faster this cycle is, the better it is. And the feedback is a key component there because you need to have fast information about your state of application and whether it's meeting your business needs or not. So how does that impact cloud native infrastructure? So traditionally, or before this cloud native came up, people used to use cloud services or on-premise services like infrastructure as a service, and you will have possibly even operational engineers watching and deploying your applications. But these days, cloud-native applications actually take some of that responsibility themselves. So you built in your own health checks, you built in your own metrics, and that takes away some of those traditional infrastructure responsibilities that used to be before. So you are no longer just relying on your infrastructure to do your reliability for you. And with this, cloud-native applications actually expect to run on a dynamic and autonomous environment. And autonomous environments usually can take decisions by themselves, can take corrective decisions by themselves in many cases. And for this reason, we have things like Kubernetes, which comes as a platform on top of infrastructure as a service. It provides you with resource management, dynamic orchestration, and service discovery and other services, which allows the platform to actually make decisions. For example, if your application says, I am not alive, Kubernetes would try to restart it or bring it back to life again. Of course, if you are using Kubernetes, you can still use Kubernetes for non-cloud native applications. So it's not a direct link. So the next few slides, we will be sharing some of the lessons or learnings that we have learned by working with customers. First, how to deal with infrastructure. The first rule that we use now is to use declarative tools for defining our infrastructure and have them continuously delivered and maintained. These tools can be like Terraform, for instance. Also, for your utility applications, like whatever monitoring tools you are using, service meshes, ingress controllers, and so on, treat them as part of your infrastructure. So if you are creating a Kubernetes cluster from a continuous delivery pipeline, add to that pipeline a step at the end that deploys all these utilities that you need. This is useful because in a disaster recovery scenario, if you are recreating the cluster, you immediately get all your utilities that you need up and running for you. And for that, of course, you need to define them in a declarative way as well so that you can have full control of what you deploy. And the last one is, of course, an obvious one, that you need to have identical or almost identical test and dev infrastructure. And also an important lesson is to actually perform all possible tests in the dev or test infrastructure. So for example, we have been bitten once by not testing load on the database that we were using for the dev infrastructure. And when we went to production and the actual load came in, then things started to break down. Another important thing to consider is secrets. How do we handle secrets? Secrets is one of the old, and it will continue to be one of the problems that we face. And there are different options that you have when you are doing continuous delivery about handling secrets. First of all, you can trust your CI/CD automation server, whatever that is, with your secrets, and then pass them to your jobs or builds as environment variables. Another option is to rely on managed services from some of the cloud providers to give you some keys to encrypt your secrets, and then you version control the encrypted secrets. Or use a self-managed secret management tool like HashiCorp Vault, for example. Or maybe there are also some offerings from cloud providers for managed secret management tools. In most of the time, we will find ourselves doing this security, which I call Mr. Bean's security model. The sound is a bit low, but that's okay. Well, hopefully your applications work after all this effort, but eventually you'll find yourself in this situation, giving some key to some tool that you will allow them to access your other secrets. So one of the options that we can use to fix this problem, if you are using Kubernetes and you would like to use HashiCorp Vault, is to actually use the Kubernetes auth configuration plugin in Vault. This basically allows you to access secrets from Vault using the service accounts in Kubernetes. So the way it works is that first you will have to configure, of course, the plugin. So you provide security policies that define what secrets can you access based on what service account and so on. And then you give your pods service accounts, which will be then matched to security policies defined by Vault. And the first step that will happen is that you could use the service account JWT, which is the JSON Web Token, which you can get easily if you are in Kubernetes. And then talk to Vault and ask for a token. The second step is that Vault will give you a token that allows you to read specific secrets. And then you can use this token to read the secrets that you need for your applications. So if we zoom in into the first pod, we can actually have an init container inside the pod, which uses the token that we have just got and loads whatever secrets you need, and then shares them as files in a shared directory or shared volume within the same pod. The last step is that your application can simply find its secrets within the same directory inside that pod. So if your Vault is actually deployed in the cluster and your pods are deployed in the cluster, then all the secret reading thing happens internally and there's no exposure outside of the cluster. Now, of course, if your cluster is compromised, then this whole thing wouldn't help you. But this is something we have to live with. Another thing that we need to care about when doing continuous delivery is how we package our applications. So it's important that your packaging makes your continuous delivery or makes your deployments easy. So you could still be doing cloud native even if you are using virtual machine images or Docker containers or whatever it is that you prefer to use. And if you are using Kubernetes, I strongly recommend that you use Helm as a package manager to package your applications. The reason is that Helm allows you to actually configure packages that you can, of Kubernetes deployments that you can reuse and publish and share with others. It also has lifecycle hooks, which allows you to do things, operational things like pre-install jobs or post-install jobs and so on and so forth. A typical example is to do backups of some data before you delete an application, for example. Fast recovery is something that has been mentioned several times in the talks before. And I can't stress on that more, but from continuous delivery point of view, you need to have a reliable continuous delivery pipeline, which you can easily trigger at any point of time to recover all your assets. The other thing is that you need to use declarative desired states, both for infrastructure and for applications, so that you can make your recovery of disasters faster and more reliable. If we do these things that I have mentioned about infrastructure, about security, and about fast recovery, then we are heading on the way for GitOps. GitOps is a term that is advocated by a company called Weaveworks. It's a set of rules or principles that you can apply with any tool stack that you choose. The idea is simple. Use Git as the only source of truth, and truth must be declarative. What you gain from this is that all your operations is actually stored in the Git history, and you can achieve all operations that you need from Git operations. So if you do Git push, you can get your desired state released. You need, of course, with this model to have a diff mechanism to actually diff the current state from the desired state. And then you can orient and make new decisions and change your desired state and go in the cycle again. If you do something wrong, it's easy. Just go back in the Git history and apply again, and you will get a rollback of what you have done. So now let's quickly do a short demo of how we do canary and dark deploys in Kubernetes with Helmsman. So Helmsman, as I mentioned, defines or allows you to define a declarative desired state of your applications, of your Helm charts, I mean. And canary and dark deploys are two types of Kubernetes deployment strategies that you could use. So let's just go into this code. So first I will I think I need to exit. Yeah. So let's have a look at this code. Basically, I have created a small application which runs a small web server that just prints a message with a version of the application. And ignoring the source code of the application, I have defined a Helm chart for my application. And the default behavior of that Helm chart is that it will deploy version 1, and it will give it 100% of the traffic. So, of course, to achieve canary and dark deploys in this demo, I'm using Ambassador, which is an API management tool that can do ingress controlling, SSL termination, and also canary and dark deploys. So inside this Helm chart is actually going to use some Ambassador annotation to describe how I want to route the traffic between my different versions. And I'm using also Circle CI to deploy, to do my continuous delivery. And this pipeline is very simple. I'm only having one job which says, or which uses the Helmsman command line tool to actually apply my desired state. Now, the desired state consists of, I have two desired states, or two separate files in the desired state. One is utilities. Yeah. So the way Helmsman allows you to describe your desired state is in either YAML files or TOML files. In this case, I'm using TOML files. And I define what credentials I want to use for Helmsman to be able to connect to the cluster, and how it's supposed to connect, what kube contexts to create or to use if they exist, and other information that are needed for connection. Then I'm defining namespaces that I would like to use. If they don't exist, Helmsman will create them, so that's another useful thing for disaster recovery. And what Helm repositories I would like to use, I'm using the DataWire repository to install Ambassador from their repository. And then what applications I would like to use and what are the configurations I'm going to use for them. In this case, I'm deploying two things. I'm deploying Ambassador and I'm deploying Prometheus, and we can deploy more and more applications. There are some other options that we can do about these applications. For example, which application should be deployed before, whether applications should be protected from further changes, and so on and so forth. So that's my utilities. Usually this should be in my infrastructure pipeline. But in this demo, I don't have an infrastructure pipeline, so I have added it here. Now the application pipeline, the desired state for the application is a much simpler one. It's still using the same connection setup from the other file, so there's no need to repeat it. And then I'm specifying some, this is the wrong file. That's one. I'm specifying the namespaces that I would like to use. I'm going to create a namespace called demo, the Helm repos that I'm going to use, and what application I'm using. So in this round, I deployed Engine Go, which is my tiny application, as or with the default values. And I have done that before the for the presentation for brevity. Is that visible enough? Yeah. So you can see that I actually have my engine Go deployed with one replica in my demo namespace. Now what I will do is, going back to my code, I will enable this line which says now deploy or upgrade engine Go with these custom values, engine Go values.yaml. And if I go to that file, I'm only customizing what versions I would like to have from this application. And I also changed how I would like the traffic to be routed. So 75% will go to version 1, 25% to version 2. So all I need to do now is to make a git commit and push it. Oh. Yeah, good point. And this will trigger a job in my Circle CI. So if I go here.
10 minutes.
Yeah, thanks. So now Helmsman is actually using both desired state files that I have provided for it. So it's parsing it, analyzing what it needs to do. First of all, of course, doing some verification that the Helm repositories and the chart exist. And then it's deploying. So if we go back to our watch statement here, then a new version is coming up. Now it's version 2. And version 1 is still there. But also, what we are not seeing here is that it has edited all these traffic routing rules as well. So if we stop this watch and do test canary, but before we run this script, let's have a look again what's inside the script. So this script is a simple script. I'm just pinging my web server, and I'm faking the host to be example.com because this is what I have configured in Ambassador. And I expect to receive a reply from the server which says this is version 1 or 2. So if we run that, or let's clear this before. And then, yeah. So we can see that I forgot to update the other one. Version 2. So in the script here, we can see that it has actually hit version 1 at times, version 2 at times, and so on and so forth. Because we have this canary deployment where 75% will go to version 1 and only 25% will go to version 2. Now let's change our configuration again. Back to the code. I'm going to go and edit my custom values for engine Go. And I'm going to wipe out these weights. I don't want that because I'm going to do a dark deploy. A dark deploy is basically where you have two versions of your application receiving all the production traffic 100%, but only the response is coming from only one of these two services. So I'm deleting those weights, and I will leave version 1 as the actual thing, and I will enable shadowing on version 2. And then again, I will do a git commit. Obviously, you should use better messaging for your git commits than I do. And now I'm going to run the same test again. And we should get response only from version 1, but the traffic should be hitting both versions. But let's see if the Circle CI has completed that deploy. Yeah, it has completed now, so we can run our test script. Oh, that didn't go well. Okay, so it took some time for Ambassador to actually load the new traffic routing configurations, because Ambassador uses Envoy as a proxy in the background. So we can see that the traffic has been hitting both eventually at the end. All the traffic has been hitting both, but only we are receiving responses from version 1, and that's called dark or shadow deploys. But of course, this is a very simplistic view of dark deploys. In dark deploys, you have to configure separate databases, for instance, and so on for the other service that's doing the shadowing. So now let's assume I want to go back to Canary deploy. So I'm going to roll back. If I need to roll back, then I can simply do git revert head, or I can go to specific commit if I want. And I'm going to push that. And as simple as that, with a git push, you are going to roll back whatever changes that you have made. So if I look at Circle CI, once again, we should see a new job triggered.
5 minutes.
Yeah. Okay, that's done. Let's this time give it a few seconds before we do the test. You think it's ready?
Yes.
Press.
There we go.
And it's back to Canary. Of course, the choice of tool that you use for enabling this routing mechanism varies. So you could use Ambassador, you could use STU, you could use any other tools that you prefer. And to end the presentation, that was the end of the fun part. So the last slide is actually some resources for those who are interested in knowing more details about these Kubernetes strategies, or a comparison of ingress controllers that can enable these kind of deployments and traffic routing. Also some documentation on Ambassador's shadow deploys. And the tiny demo application, it's called Engine Go. Actually, it's stolen from Mike here. So. And that's it. Thank you very much.